Let's look at another example of how we can do multiple regression in Excel. Remember that multiple regression is when we have a lot of data on people, and there's one thing that we're interested in predicting from other people. So in this example, we want to predict people's job commitment, and we're going to call that Y. Now we have a lot of data on the class, and first of all, we're going to try to predict one of the first variable that we're going to use is how much someone likes the Kardashians. Now, I don't know if that's a very theoretically legitimate predictor for job commitment, but we'll see if it works. And then secondly, the quality of his or her relationship with the boss. Now, for this one, the job commitment should be positively related to the quality of relationship that one has with the boss, because the way that we've been created is that relationships are so important that we are more likely to stay in something when we have a high quality relationship. So here we have the data for the class, how much people like the Kardashians. Wow, there's a lot of ones there. One's low, 5 is high. The quality of the relationship of their boss, which is a composite variable. It was the average of 3 questions, and then their job commitment on a scale of 1 through 5 also. So the job commitment is going to be our Y, what we're trying to predict. How much they like the Kardashians is going to be X1, and the relationship with boss is going to be X2. So we go to data, data analysis. We choose regression. Okay, and it says, what's the Y input range? The Y is what we're trying to predict, job commitment. The input of the X range is going to be all of these 2 variables, the Kardashian and relationship with boss. So we're putting both of those in. We have labels in the top row, Kardashian, relationship with boss. The output range, I want to put right next to it. So I click on output range. Now I've got to click in the box here so I don't lose the input. And I'll put it over here in G7 and press OK. I'm going to get this big wall of numbers. So let's reduce the number of decimal points. Home, number, reduces it to 2 decimal points. Let's make these columns wider so that we can read them. There we can read everything there. This one, let's make this wider, and this one wider. Now these other things are important, but we haven't looked at them yet, so we're not going to be too concerned. So what do we have that's important? The R squared, that's only 35%, 0.35. So it's predicts about a third of job commitment, how much you like the Kardashians and the relationship with your boss. And then we have the coefficients and the intercept down here, and we need those information, and we can put this together. So into the equation, Y equals, and we put a space before the equals, space after equals, then the X1 is the Kardashians, so it's minus 0.71 X1, and I'll change that into a subscript later, plus 0.49 X2 plus 1.87, the coefficient, or the intercept we add on at the very end. So it's the Kardashians times minus 0.71 plus 0.49 times the relationship with the boss plus 1.87. Now let's make these into subscripts. I'm going to highlight the 1, go to font, subscript, OK. I'm going to go to 2, highlight 2, go to font, subscript, OK. And so what this basically says is the more you like the Kardashians, the lower your job commitment is. And the more you like your boss, the higher your job commitment is. And we can multiply them by these 2 numbers plus add 1.87, and that'll give us an estimate of your job commitment. So this was using multiple regression with 2 predictor variables to predict job commitment from how much people like the Kardashians and the quality of the relationship with their boss.